We have an AC circuit here. I think the first step is going to be to find the impedance, right? So we have that the impedance is equal to the max voltage over the max current, or RMS voltage over the RMS current. Let's see, we're given the max voltage and we're given the RMS current. Let's go ahead and find the RMS current. The RMS voltage. Okay, so the RMS voltage is equal to the max voltage divided by the square root of 2. So that's 120 volts, right? So Z is 120 over 22 amps. And that is 5.47 ohms. Now in this case, since we don't have a capacitor in the circuit, we can say that Z squared is equal to R squared plus the inductive reactance squared. So that's 5.47 squared. Now the resistance is given to be 4.5 ohms. Okay, that lets us solve for x sub L squared, which is 9.63. Now we're going to set, well, that means that x sub L is 3.10. We're going to set that equal to 2 pi FL. So L is 3.10 over 2 pi times the frequency. Now the frequency is given to be 45 hertz. So that's 0.011 henries. Okay, so there's part A for you. Part B, the maximum possible voltage drop across. Well, we're going to need the max current. So the max current is the square root of 2 times the RMS current. That's 31.1 amps. Okay. Now the max voltage across the resistor is simply the max current times the resistance. So 31.1 times 4.5. That's 140 volts. Now the max voltage drop across the inductor, well, that's the max current times the times the inductive reactance. So that's 31.1, and we have the inductive reactance up here. That's 3.1. So that works out to be 96 volts. Okay, now part D. We're at max current, right? So the first part's easy. If the current is equal to the maximum current, then the voltage drop across the resistor is also equal to its maximum possible value, which we've already found is 140 volts. Right? We say that the current is in phase with the voltage drop across the resistor. The voltage drop across the resistor goes directly as the current does. Now the inductor is another story, right? At I max, right, if you've got a graph of current over time, and let's say it's doing something like this, right? Well, at I max, the slope is 0. Right, this is I versus T. And delta I over delta T, the slope of that graph is 0. Okay. Well, the voltage drop across the inductor goes as L delta I over delta T. So that's 0 at that time. And then the voltage drop across the source, well, we get that from the loop rule. Right, so that's just 140 volts. Now, we can do the loop rule because we're at a particular moment, at I equals I max. We can't use these two quantities with the loop rule because these voltages occur at different times. Right, the maximum voltage drop across the resistor occurs when the current is maximized, which is here. The maximum voltage drop across the inductor occurs when the slope is maximized, and that's here. Since those occur at two different times, you can't use the loop rule. The loop rule only works at any given instant, which is where we're at in this problem.